Students, we will discuss properties of real numbers. First of all, we are all familiar with the following sets. First set of natural numbers, it is denoted by n, and the elements of this set are 1, 2, 3, 4 and so on. Then we know that set of natural numbers is embedded in the set of integers, and the set of integers is denoted by z. Elements of this are all natural numbers 1, 2, 3 and so on. Their negatives -1, -2 and so on, including 0. Further, integers are embedded in set of rational numbers. Rational number, that any number that can be put in the form p upon q, where p is integer, q is a natural number. GCD of p and q is 1. This round bracket is notation of GCD, greatest common divisor. But Pythagorean discovered that the diagonal of a square with unit sides could not be expressed as rational number. In view of Pythagorean theorem for right angled triangle, this implies that square of no rational number can be equal to 2. For example, this is a right angled triangle OAB with OA and OB are unit sides. Applying Pythagorean theorem, which states that the square of hypotenuse is equals to sum of the square of other two sides of the right angled triangle. So we get OB square equal to 2 units. It means OB is equal to under root 2. So that is, there are numbers in the system which are not rational numbers. Such type of numbers are called irrational numbers. So irrational number, any number which cannot be put in the form p upon q. P is integer, q is a natural number, p and q have GCD 1, is called irrational number. Then we will define now real numbers. So real numbers, union of all rational and irrational numbers is called set of real numbers. Set of real numbers. Set of So earlier I have explained that there is no rational number whose square is 2. Let us prove it analytically. So theorem, show that there exists no rational m such that m square equal to 2. Proof. Suppose, if possible, there exists a rational number m, p upon q. P is integer, q is a natural number, GCD of p and q is 1, such that m square equal to 2. It implies 2. So means p square is equal to 2q square. Now right hand side is 2q square, it means right hand side is an even number. So it implies p square is also even number. So if p square is even number, it means p is also an even number, because if suppose p is odd number, then we know that square of odd number is odd but here p square is even, so p cannot be odd. So therefore p is even number. So let p equals to 2r for some integer r. Put into we get as before q is even, integer, so it imply both q are even integers. It imply their GCD cannot be equal to 1 because 2 is common in both, which is a contradiction to 1. जो हमने पहले इक्वेशन 1 मानी थी उसको क्या आ गई है contradiction, which is a contradiction to 1. So therefore there exists no rational number m such that m square equal to 2. Means there are numbers which are not rational numbers, and number of such type are called irrational numbers. So real numbers, all rational and irrational numbers are called real numbers.